Hi, so my name is Thibaut, and I will show you how to analyze your models inside Peccary. And the idea of Peccary is that these analyses are strictly independent on the software you are using. So either you do your model estimation with Monolix, NONMEM, nlmixr, it's the same things, and we might add any other softwares very easily, like Phoenix, for instance. So to demonstrate that, I have here a folder that contains lots of different runs, which are from NONMEM, Monolix, or saemix. And what I do is I just copy that. I go on model analysis. So on the folder, so for the first time you have an error message, it's normal because the folders have not been created. I just pass that, so the path of these folders, and I click on go. And so when you do that, Peccary analyze all the folder and subfolder and subfolder contained through these folders and finds any runs that are from Monolix, nlmixr, or NONMEM, and it also provides you, for instance, the objective functions to have a quick overview, except for the moment for nlmixr where the objective function is not available. And the most important thing here is that you have a number for each of your run, and this is the number you will use to make a reference to this run. So if you have too many runs, you can switch from a subfolder to another. So let's say you want to look only about the runs inside this linear elements. You click here and you click there, and then you have only these runs. So you can go back and forth like that. And then what you have is, let's take for instance the Simioni model. So here you have two numbers. So if you have a number 27, click on them, then you have the summary of your runs, so the number of subjects, observations, parameters, the criteria score, and then you have all of your parameters. And the beauty of the thing is that if you want to compare now with the run number 28, you just have to do that and nothing more. And here you have one column equal to one run, and you have a full join, and so you can compare every parameters, how close or how far they are from one to the others. So if you have five numbers, here you will have five numbers. You can do something like that. For instance, you can also say I want to run 27 to 28 minus 28, for instance, and you have only 27. So because unfortunately I can't show you every run because some of them are confidential. So we'll do with that. And then you have the prediction. So let's take just for instance one specific runs. You click on predictions, and what you will have is an analysis of the model. So here you have one column per equal type, so 1 and 2, and you can make some filters. So for instance, if you want specifically like the ID number, I don't know, this one, you click on update plot, and then you have this number. So let's take I don't know, more, and if you want to have more runs, well, you can perfectly have more runs like that, and then you will be able to compare. So for let's take only 4 of them. So here you will be able to compare the run, how far they predict the difference between the runs. So I made on purpose a run with a good fit and one with a terrible fit, and so it's very easy to compare runs together. You have the same thing for the, so you have several then other filters or things like that. You can change the logarithmic scale, of course. Here is, for instance, if you don't want to go below some values, you can say I don't want to go below these values, for instance, and things like that, but it's not worth to make details about everything. So here is for the goodness of fit plots. So the idea is at first you have every run that can be observed for one specific run, you can remove some filters. So let's say, for instance, you want only a specific equal type, so you want equal type equal 2, for instance, you can do that, and then you will have only equal type equal to 2. And you have here, like, if you want to have several runs, so you see there that you will have every run that can be printed. And so here you can say, okay, let's say I want to compare specifically these plots. So I can say, for instance, I want to look at only up versus spread, but I want them to compare from one run to another, and you can compare everyone. So it will work if you have lots of runs. Like, for instance, also something that I did not show you, like, let's say how potent it can be. Like, I think here, like number 17 to 20, if I do that, 17 to 20, I will be able to compare sorry, because the filter here is preposterous. So I'm able to compare some a run which is from Monolix and a run from nlmixr. So you can even compare some runs that does not belong to the same, that has not been estimated with the same parameters tool. But let's go back to the Simioni here, 27 to 28. So you have the same thing for almost everything. So here it's to analyze some parameters, some covariates, and what you can do is, if you have several of them, you will have a color, and you will see the asymmetry between the runs. So it might be very interesting to have this. And so if you have 5 runs, you will have 5 runs with this kind of colors. For matrix, is the same thing. So by default, you have only 1 runs, and it will be the this. And you can say, okay, let's say I want specifically, so you have a filter here, and let's say you want only to look at the clearance, for instance. So here you have all the plots by default, and here you see what you will have as plots if you do here. So I want from runs 27 to 28 with multiple runs actually, and you will see that normally you will compare one of the elements to the others. And so of course you are not constrained to have only one type of plots. For instance, if you want I don't know, every plot related to the clearance, you can say that, for instance, and you will have every single plot related to clearance. So in this case that, and so for each one of your plots you will have the first one and the second one. And okay. Then what you have is ELL. So the idea of this function is that you have the difference of individual look likelihood for each patient, and you can choose then a covariate. So for that you have to load covariates, you have to here have the same number as here. So it's quite not the best tool, it must be improved. But then you can say, okay, I want to look at that on the dose, for instance. And so you will have for each ID the difference between the two individual objective functions, and you can colorize it by a covariate. And it might be interesting sometimes to see that actually one has a better objective function than the other, but in fact it only improves one specific subgroups and detail, and is worth for lots of patients. So it might be interesting in some case to do that. I won't show you the other things because, well, it must be improved for the moment. Just one thing I forgot to mention, when you have the number here, you can also go to model building and go on import model and put just a number here and click on launch, and then you will import directly the model inside the model building systems, where you can load plots, for instance, and you can, here it was for Monolix, but you can then translate into NONMEM and maybe even into nlmixr. It's also possible to add your own function quite easily actually, and even inside the Shiny app without modifying any files. So here for instance you have the by default Peccary function that I personally wrote, but a co-writer Crystal did her own function, and you can use a function by clicking on that. And so when you do that, you will see that you will have her own functions, and it's not the same. Like if you look at that, you see you don't have the same uh, input elements. So when you do have that, you have a own, and well, the stratification is the best parameter for them. And like for instance, she did quite the same thing, because in my functions you have on left equal tip equal 1 and on the right equal tip equal 2, and what she did is she gather for each ID all equal types. So it's a different way of reproducing that, and that's why it might be interesting to multiply the different functions that are available. And so I won't explain how she added the plot inside Peccary. It will be a specific video, but it's just to show you that you have several ways to participate to Peccary, and of course because she added the function of Peccary, her name is written in the author sections listed in alphabetic order. So I think this is it for the model analysis, and so I will show you in another video how to improve that and how it really works internally inside Peccary. Goodbye.